Hello and welcome to today's webinar, How to Build a Successful Cloud-Native Application Delivery Strategy. My name is Jeremy Schwartz and I will be your host for today's presentation. Our featured speaker today is Pankaj Gupta, Senior Director, Cloud Native Application Delivery, and Miko Decini, Director of Cloud Native Application Delivery at Citrix. Before we get started, let me cover a couple of housekeeping details. We will have a dedicated question and answer session today at the end of the session, and we invite you to submit your questions at any time during the presentation using the Ask the Question window in the webinar interface. Also, this webinar is being recorded and a link to the on-demand version will be sent to everyone in a follow-up email. With that, I will now hand it over to Pankaj to start the presentation. Welcome and thank you so much for joining us.
Thank you, Jeremy. Thank you, audience, for taking the time today to learn about how to build a successful cloud-native application delivery strategy. Many of you have already built cloud-native applications or planning to build now. Cloud-native applications is the latest and the greatest phenomena, and it is happening now, and it is changing everything. As per a leading analyst firm, more than 75% of global organizations will be running containerized applications in production by 2022. Reasons for moving to cloud-native applications, also known as microservices-based applications, the key drivers are agility, the ability to roll out the new software releases, new updates much quickly, taking large monolithic applications and turning into manageable, modular micro applications which can be updated individually, and also portability of individual container-based microservices which can be ported across the hybrid multi-cloud. And these microservices can be replicated by auto-scale for your ever-changing traffic needs. Cloud-native applications also require a very high degree of infrastructure automation, security, monitoring, and networking. This really helps DevOps team to deliver and deploy new applications faster, updates much faster. And one more critical point, most of the container-based applications are using Kubernetes platform today. When you are looking for cloud-native application delivery solutions, you have to consider 5 critical things. Number 1, what is the right architecture? Does it work with your environment and your tools? Because you want to take your applications fast to production, and it should be able to support your choice of Kubernetes platform and also open source tools. And many of your open source tools can be from CNCF if you choose some. We'll be spending good amount of time today going through the various architecture options, pros and cons, giving you the framework to balance between complexity and features so you can choose the right architecture, whether you are a cloud-native novice or an expert. Third area which you have to look at to evaluate various solutions is performance and scale. You should be able to support large number of clusters and also have ability to support very dynamic microservices. That means that they can come and go. You should be able to load balance among various microservices pretty quickly. Security is paramount. We are living in an application and API economy, and you have to extend your security to microservices-based application. And it has to be deeply integrated into your microservices-based application delivery. Fifth key criteria which you have to consider is the actionable insights. Kubernetes or microservices-based applications are very complex, and they deliver mission-critical capabilities to your users, customers, partners, employees. So you really want a very high uptime, and that's where you're really looking for a very high visibility and tools and insights to troubleshoot problems faster. And these criteria are in more like in serial order. First, you look at what is the right architecture you are going to choose. Does your vendor support that? Second, can the solution be integrated with your work, with your IT environment and tools? Does it offer right performance and scale? Does it have an integrated application and API security? And does it give you the right tool to troubleshoot problems faster and gain a visibility into a microservices application delivery environment? And across these five, two other characteristics is very, very critical. Production-grade solution and addressing the needs of multiple stakeholders, which we are going to talk pretty quickly in next upcoming slides. Starting with this framework, next thing which we are going to talk about, what is the Citrix solution portfolio looks like for cloud-native applications. It is collection of 4 building blocks. The number one is application delivery controllers, which many of you are already very familiar. It is a best-in-class. Now it comes in multiple options based on your architecture, physical, virtual, bare metal, and in containers, and as well as a sidecar option if you are considering a service mesh architecture, which we are going to go into detail. The second one is ingress controller, which makes your ADCs container aware, gives you the control plane, and it is deployed as a container inside your Kubernetes cluster. For management and control, application delivery management, which gives you automation, visibility, and much more. And you can deploy that as a container on-prem, on as a service. And across these 3 building blocks, the common 4th building block is the integration ecosystem. 3 sub-areas there. One is the cloud-native platforms. If you are choosing that, like Red Hat OpenShift, cloud-managed Kubernetes. If you are considering to deploy these applications in public cloud using one of the 3 major ones, AWS, GCP, or Azure, we support all 3. And also your open source tools for visibility, logging, matrices, and much more. And Citrix portfolio is much broader than just cloud native ADC portfolio. Citrix ADC portfolio is built for hybrid multi-cloud, which is very comprehensive, feature-rich, and what differentiates us is being a software-centric and having a single software code base across multiple form factors and deployment models of Citrix ADC. That is also a big differentiation for us. The benefit of single software code base is the operational consistency. You can deploy any Citrix ADC in any form factor, any location, any cloud, any deployment model, all have similar and consistent features. So you need not to learn anything new. You can manage them through a single glass of pen, which other competing or parallel solutions do not offer. And using Citrix hybrid multi-cloud solution, you can deploy, manage not just the cloud native applications, but also your existing 3-tier web application through a single pane of glass with the feature consistency. That is a big care about for you if you are building the new cloud native applications or even migrating your existing 3-tier web applications into a microservices-based applications. My colleague, Miko, is going to go more into detail in upcoming slides when we talk more about architectures. But before we do that, let's look at who are the stakeholders for cloud native application delivery and how each one of them has their unique needs, and the architecture which you choose has to satisfy the unique needs of multiple stakeholders. In the center of this slide, or the biggest stakeholder and most important one, is the platform team. The platform team is the team who runs the Kubernetes platform and responsible for 3 critical functions. One is the platform governance, operational efficiency, and delivering the agility which each and every developer really wants. Platform team plays a much bigger role than beyond these 3 we just talked about. They are the connecting tissue between other stakeholders, whether it's a DevOps, developers, SREs, site reliability engineers, network operations, or DevSecOps. DevOps really care about the faster release and deployment cycles. They're looking to really embrace continuous integration, continuous delivery, and bring more and more automation, deploy advanced techniques like canary and progressive rollout. Developers are looking from this architecture as delivering a great user experience and how fast these microservices are discovered and traffic is routed effectively to that. Site reliability engineer has North Star for application availability. They need a tremendous observability to know how each application or each service or each pod is really performing. If something happens, how fast and how quickly they can respond to the incident, and doing a postmortems to make sure those incidents don't happen in future. The NetOps teams who have traditionally run ADCs or managed They care about network policy, compliance, managing network, and monitoring it, and also some part of the resource and capacity planning. While DevSecOps is really about application and infrastructure security. They want to make sure containers are secure, APIs, gateways are doing their function. They also care about automation. So what you see here is a multiple stakeholders and each having a unique need for choosing the right architecture. Based on these multiple stakeholders, their unique needs, Citrix has developed a unique framework to evaluate multiple architecture options on 7 criteria, and we are going to go deep into pretty soon in upcoming slides. Let's look at what are the 4 architectural choices you have. They are plotted in 2 axes. Horizontal axis is complexity, and on vertical axis you see the benefits. The objective here is that how do you balance the trade-offs between benefits and the complexity. The simplest and easy to deploy for production is the 2-tier ingress, which you see in the left lowermost corner. There is a variant of 2-tier ingress, which is the unified ingress, which gives you very similar simplicity of 2-tier ingress, but also gives you additional benefit of reducing 1 hop, but that is more suitable for platform teams who are very network savvy. North Star for emerging architectures is service mesh on the rightmost upper corner. That gives you the best observability, best security, best or most advanced traffic management capabilities between various microservices, but it is also the most complex. Many customers who want service mesh-like benefits for observability, security, and advanced traffic management, but want less complexity, they consider service mesh-like, which gives you service mesh-like benefits, but much simpler to deploy. Only Citrix offers these 4 solutions or architectures, so you can move to the cloud native applications at your pace, irrespective of whether you are a cloud native expert or just starting with your cloud native journey. Let's look at each architecture into detail. First one is 2-tier ingress. Key takeaway of this architecture, it is simplest and quickest to deploy, take your applications to production, and it is equally loved by cloud native novices and experts. Let's start from the left-hand side to have a little bit deeper dive into this architecture. As it is called a 2-tier ingress, it is north-south traffic is split into 2 ADCs. One is the green ADC you see here, another one is the blue. North-south means the traffic which is coming from users and is steered into your Kubernetes or microservices cluster. Second term you will hear is the east-west traffic. East-west traffic is the application traffic between or among your microservices. That is called the east-west traffic, and we'll be using east-west and north-south traffic multiple times. And you have to evaluate your architecture on both traffic types, east-west and north-south. North-south is bringing the traffic into your Kubernetes clusters, and east-west is the traffic among your microservices. Let's go back to this architecture again. For north-south traffic, you have two ADCs. One is inside the Kubernetes cluster, one is outside. The green one is managed by networking team. It does north-south layer 4 load balancing. You can also implement many security features like SSL or web application firewall, and that product can be any Citrix ADC in any form factor. The blue ADC, Citrix CPX, is inside the cluster. For north-south traffic, it provides a very feature-rich layer 7 load balancing. It is managed by platform team. The benefit of splitting north-south traffic load balancing between two is that two different teams can manage their own domains, and network team need not to learn anything new, and platform team doesn't need to learn about SSL and WAF and many other north-south traffic related. So it gives a clear demarcation, and that's the reason it is simplest and quickest for production. For east-west traffic, each Kubernetes node has a layer 4 load balancer, and typically it is a kube proxy, which is open source. The benefit of kube proxy, it is simple, it is open source, but you have to be aware it only does basic layer 4 load balancing. It can only do the round robin load balancing between the nodes. If you're looking at advanced load balancing between your microservices and canary deployment, it simply doesn't have that capabilities. Let's look at the 7 criteria which we drive from multiple stakeholders' requirements. First is application security. Green means good, yellow means somewhat okay, red means it is a challenge. For application security for north-south, Citrix ADCs offer an excellent protection, but for east-west traffic between the microservices, you have to deploy network policy, segmentation, which kubeproxy doesn't offer. So you have to deploy additional products like Project Calico, but it still gives you the only very basic network policy and segmentation. For observability, every packet for north-south traffic goes through Citrix ADCs. So it has the complete visibility, but kubeproxy have very limited capabilities for telemetry So that's the reason it is red here. If you are considering advanced continuous deployment of things like Canary or progressive rollout, you can do extremely well with north-south traffic through Citrix ADC. But for east-west traffic, Kubeproxy has only very basic layer 4 load balancing. So it becomes a huge challenge if you are considering advanced things like Canary deployment, automated Canary analysis, or progressive rollout. For performance and scale, all the ADCs for north-south scale extremely well. You can do the clustering. But if you are considering east-west, we recommend to use IPVS mode instead of IP tables mode for Kubeproxy to get a better scale. If you're considering open source tools, you get an excellent support for north-south traffic, but due to limitations of Kubeproxy, you cannot integrate with many of the open source tools like Grafana, Prometheus, EFK, and many others. If you are considering an open source control plane like STL, you can integrate very well for north-south traffic. And for east-west traffic, Kubeproxy simply doesn't have API support today. So in a nutshell, if you are really considering great features for north-south traffic, but basic functionality for east-west traffic, great features and functionality for north-south traffic, but what very basic for east-west, it is a great architecture for that. And if your primary objective is simplicity and quickest to projection, this is the architecture for you. Let's look at the next variant of that, which is unified ingress. The difference from this architecture versus the previous one, we have collapsed two-tier ADCs for north-south traffic into a single ADC. The benefit of that, you reduce complexity of one ADC tier. You also reduce one hop latency. Benefits are exactly same as the previous architecture, so we're not going to go into the details. But the key requirement for this deployment, your platform's team have to be very, very network savvy, and if they are not, they have to learn it. Many of our customers consider this architecture to start with internal applications facing their employees, where they don't care much about WAF and SSL functionality, but they want to add it later when they want to use the same architecture to add external applications also. It is a good architecture to consider if your platform teams are really, really network savvy and still want a very simple solutions to deploy, great features for north-south traffic, but very limited functionality for east-west traffic. Next one, we move to the north-star architecture, which is the service mesh. There have been a lot of discussion in market today about service mesh. Many of the architects are really considering this as a north-star architecture. It has emerged as one of the most sought-after architecture in last 2 years. However, there are not many deployments in the commercial deployments yet. The promise of service mesh is the best observability, best security, very, very secure traffic among the microservices. If you're building financial applications or applications for national importance, this is the architecture to consider. If you are very progressive, far ahead in continuous integration, continuous delivery, wants to have canary and progressive rollout and many advanced features, having a very fine-grained traffic management among the microservices for East-West, this is the architecture to go for. But it's also very, very complex. There is a huge learning curve. So let's look at this architecture a little bit more into detail. For North-South, it is very similar to what you have seen in the first architecture. The key difference is for East-West traffic. Here, for each microservice pod, there is a sidecar attached. Think sidecar as a mini application delivery controller. And for that, we offer Citrix CPX not just as a container, but also Citrix CPX as a sidecar, which you can attach to each pod. And the traffic or communication between these microservices pods happens through sidecar. Each sidecar has its own CPU allocation, its own memory allocation. It has visibility of every traffic between the microservices. It has a more advanced traffic steering capabilities, more APIs. And having its own CPU and memory allocation, you can actually offload some of the repetitive application functions to these sidecars. These functions can be retries, encryption, circuit breakers. Those are all very advanced topics of service mesh. Let's look at the benefits for that. For East-West traffic, these benefits are exactly the same what you see in the previous two architectures. The real difference is for East-West traffic, which is the communication between the microservices. For application security, as each sidecar is attached to each microservices pod, you can do mutual TLS, you can run encryption between them, you can assign which microservices can speak to which microservices. That is all built in. As every traffic between the microservices applications goes through this sidecar, it gives you tremendous observability. It has APIs for continuous deployment with products like Canary or Citrix ADM, for Canary deployment, for advanced Canary analysis, or for red-blue deployments, or for even progressive rollout. The scale and performance for East-West really benefits from distributed architecture of these sidecars. But please make no mistake, the performance is dependent on what kind of sidecar you are using. There are some sidecars in the market which can access up to 6 milliseconds of latency, but if you use Citrix CPX as a sidecar, your latency could be close to 1 millisecond. But also be aware that if you're using this architecture, it adds 2 hops of the latency. As sidecars are intelligent, they can support much more APIs. It offers excellent open source tool support, which Miko is going to talk pretty soon. This is also a great architecture if you want to bring an open source control plane like Istio for east-west traffic also. But it is complex, and platform team has to really learn, experiment. It has good learning curve for for platform teams. To summarize this, best observability, great security, very fine-grained traffic management for all east-west traffic, as well as for north-south, but it's very complex. So what if you really wanted all these service mesh-like functionality, but want to have a much simpler configuration? And that's where Citrix has been working on a service mesh lite, which gives you secure traffic among microservices, great visibility, point-grade traffic management, observability, but with much less complexity. So how do we simplify that? The simplification comes by using a centralized application delivery controller as shown in the purple ADC inside the cluster. All the traffic between the microservices pod goes through this purple Citrix ADC or Citrix CPX. And that Citrix CPX in purple has the visibility of every traffic. It could be the enforcer of the policy. It could be the enforcer of security. It could be the intelligent load balancer to do an advanced traffic load balancing features, which we just talked about. And the skill set learning is hardly any new. It is pretty much at par with the first simplest architecture which we saw, where platform and networking teams need not to learn anything new. To summarize, if you really love the service mesh features like advanced security, observability, continuous deployment, Istio support, but make it very simple, this is the architecture to go for. With this blueprint of 4 services, 4 architecture, which one will be your architecture choice? If you need simplest and quickest, 2-tier ingress. If your platforms teams are very network savvy, unified ingress. If you need best observability and security, but willing to learn and manage the complexity, service mesh is the dream architecture. But if you want service mesh like functionality but much simpler, service mesh lite. There is no right and wrong architecture choices. It purely depends what features you want, what functionality you want, for a granularity for east-west as well as for north-south traffic. If you need more discussion, our sales team will be happy to have a much deeper discussion with you. We'll be publishing in upcoming days more white papers and more insights about these architectures. But let's also learn about what Citrix solutions for microservices offers. Miko.
Thanks, Pankaj. Hi, it's Nico Decini. So we talked about Kubernetes platforms and their architectures for inserting ingress so that you can expose apps to the outside world or to traffic, to clients that need to hit the apps. One thing we're learning is that in these architectures, a few things. One, customers are looking to use their existing ADC footprint for ingress, or 2, they want to be able to insert ingress container solutions inside the clusters. And so we've covered that in the architecture choices discussed today. In addition to that, we've discovered that our customers, if you look at their stakeholders, the app developers or the SREs or the DevOps folks, they're looking for one immediate feedback from their apps and to being able to use existing, whether it's a tooling like CI/CD or being able to use modern tooling for CI/CD. That's cloud native. In looking at this, we've focused on giving immediate feedback to the app developers and SRE teams, and we have a rich set of metrics from NetScaler, Citrix ADCs, that we now provide connectivity to Prometheus, and with that you can get data on SSL, TCP, UDP, HTTP, HTTPS stats, and this can be visualized through Grafana. So with that, you can look at latency, you can look at connections, important information about your deployment. Second is that in addition to metrics, users are looking for log information, so connections and so on, and error counts. So that's all available, or failure rates, and so on. That's all available through NetScaler through integration with FluentD and FluentBit. We have a container that aggregates logs from multiple endpoints, in this case, different NetScaler Citrix ADC solutions that act as ingress. And so support for FluentBit, and then we can send that to Elasticsearch Stack, and then it can be visualized through Kibana. So in addition then to metrics and logs, we also support distributed tracing. It's available in Citrix ADCs in release 13.0. With distributed tracing, we can then visualize the tracing data using Zipkin, which is again an integration we support. In addition to that, we have an integration to CI/CD using Spinnaker as the initial integration, where we can automate the CI/CD pipeline process. So with Citrix data being sent to Spinnaker, this data on the apps, we can create canary deploys and apps. The data on the apps that's being deployed, we can then tell Spinnaker, which has a judge called Kayenta built into that now, to tell them whether the app is doing well, we don't see any errors or latencies, or we send data back, or the app actually seeing some errors and latencies, and therefore Spinnaker with Kayenta will then come up with a score, and based on that score, decide whether to continue with the app deployment or roll it back. So I've covered that's the Spinnaker integration. Now we started with Spinnaker. We're of course looking at integrating other tooling, Spinnaker being the first. And then we support certainly simplified deployments like Helm charts using Helm. We support now as well operators through CoreOS. And then we support gRPC, HTTP2 with gRPC. And on top of that, we understand that customers are deploying our platform, they're deploying their own enterprise-grade platforms from key vendors like Red Hat, OpenShift, or Pivotal, and so on, or Rancher. So we have integrations with these key platforms, as well as support for cloud-based managed Kubernetes services, GKE, AKS, and EKS with Amazon. Finally, not finally, but in addition to that, this is a fast-moving space. There's a lot of work being done in the industry around service meshes, and Istio being the first, the control plane that service meshes come out. So we support as well Istio as a service mesh for control plane. So with that integration, the key product we provide, in addition to a visibility stack, are proxies. And one proxy I like to point out is the NetScaler CPX, and we'll talk more about that in the next slide. And our proxy sits inside the Kubernetes cluster. It can act as both an ingress device or as a sidecar. That sidecar functionality is coming out in the next few weeks. And so it comes in multiple sizes, very small footprint, ideal for sidecar use case, or sufficient size footprint, ideal for ingress use cases. It's designed for high performance and latency. What I mean by that is you can add more capacity to it. You can support more traffic, connections, bandwidth, SSL, TPS, and so on. required for the north-south use case, and as well as and a smaller memory footprint, therefore for east-west service mesh use case. In all of these deployments, our latency is extremely low. One thing we have is a very fast proxy, so we're seeing latencies in the 1 millisecond or time frames, whereas we're seeing open source proxies that are in multiples of that. And we're seeing this particularly in as you add more connections and therefore more traffic to these clusters at P99, for example, or P95 to P99, that Citrix ADC performance is more stable compared to open source proxies. Therefore, you get more data, you get a better user experience, what we find, at least in our data with Citrix ADCs at these levels. And as these clusters can change rapidly with new apps being deployed, auto-scaled, or apps being taken out. Our APIs are very fast, such that all the app changes, topology changes, can be reflected in configuration changes in Citrix ADCs. And in addition to that, as these changes are made, there's no requirements. We don't have to reset or restart so that new configurations will take into effect. We can do this on the fly. We mentioned the proxy. Now, let me talk about the control plane and observability. We have a platform called ADM. Citrix ADM think of it as a control plane and an observability plane that runs as a service as well as a software that can be deployed on-prem. And it is integrated with Kubernetes. It also integrates with with all of Citrix ADC endpoints, proxies, and platforms. These platforms will send data to ADM, and ADM can then be used to visualize your microservices, your applications, whether it's 3-tiered applications or whether it's an application that runs in Kubernetes, and we can visualize this application, visualize the microservices, and identify fault points, latencies, errors, and so on, and so that you can debug fairly quickly if a problem arises. We have built a service graph for that, and we'll show that in the next slide. Meanwhile, we support multiple kinds of NetScaler proxies, whether it's an existing appliance that are deployed in a data center, the MPX, or the SDX, which is the multi-tenant appliance. We also have a bare metal solution called the BLX we're shipping, and container solution called the CPX, and a solution that's run in the public cloud, whether it's CPX or VPX. And then the VPX is the virtual appliance. So we have multiple form factors, and these form factors have the same code base, and therefore you don't have to change your tooling. Once you support one form factor, you have support for the rest of the form factors. So we're seeing customers using the existing ADCs and then moving over to a virtual solution or a container solution and transferring their policies or requirements for those particular. And you can do that quite easily with Citrix because the code base is the same. Okay, and then the next slide then talks, I mentioned how we can simplify your ability to troubleshoot. We have a service graph that we've built on ADM. This is the initial generation service graph. We've since iterated this, but it shows we read the data from the API server and Kubernetes. We can populate based on the labels what the microservices are. And if the traffic is hitting NetScaler, Citrix ADCs, our proxies, then we can tell bandwidth, connections, error counts, latencies, and so on. And we can then show that here and then change the color if we see that it hits a particular problem point. And really, the goal here, the feedback we get from customers is once we deploy their applications, they really want to know fairly quickly if there's something going wrong. And you want to know how, and just drill down and figure out what metrics are being hit. And so that's something we built with Citrix ADM, and that's shipping as a cloud service. The cloud service will be the first version where the service graph will be available, and that's shipping very shortly within the next 2 to 4 weeks, I believe, it's shipping. And then we'll ship the on-prem version about 1 or 2 quarters later. And finally, just to recap, our solutions that we've built allow our customers the ability to go fast the production grade speed that they need provide a production-grade solution at the speed of the business. So they don't need to go fast. We allow them to go fast, but with a high degree of safety using production-grade solution from Citrix. The solutions we have allow you with architecture flexibility. You can move, essentially, you can decide what architecture to use based on your speed. You can go the two-tiered architecture. It's simple, or you can go, if you're more advanced, you can go with the unified ingress. Even further, if you want full observability but still simple, you can do Service Mesh Lite. If you want the full benefits of observability, full fine-grained control, that Service Mesh to provide those architecture flexibilities. And in addition to that, once you have that, we can also provide compatibility with different Kubernetes platforms. So we support different types of platforms that are in the industry, managed-based platforms as well as enterprise-grade platforms. If you have existing tooling today, CMCF tools like Prometheus and Grafana, Zipkin for tracing, Kibana, FluentD, FluentBit, we support those as well, so we can provide metrics and logs to those tools, so that developers and DevOps and SREs can use their existing tooling and getting the data directly from Citrix ADCs. And we are designed for production, so for high performance and scale. So we support anything from small to large clusters, and regardless of the speed, regardless on the number of apps, regardless on the topology changes, we are fast support for changing configuration. So our APIs are very quick. Finally, and the last 2 points here, we provide insights based on the data we have on Citrix ADCs that we can then send to ADM for a very rich service graph, and that allows you to troubleshoot your problems faster. And since we have functions on, we didn't cover this as much, but we'll cover it now. We have such functions like SSL, WAF, authentication. We can protect your APIs, and we can expose these functions as CRD so that they're developer friendly. And this is an area we'll continue to innovate. So you'll see us innovating, adding more API gateway functions in our solution. I believe that covers it, Pankaj.
Back to you, Jeremy.
Okay, our first question is, if we are beginning the journey, what architecture do you recommend and why?
If you are just beginning the journey, the architecture which we strongly recommend is two-tier ingress. There are 3 reasons for that. You have a clear demarcation between your existing platform team and networking team. There is a much less learning curve, or actually hardly any, for both teams. You can get your applications to production pretty fast and have a quick win. And this architecture also gives you option to move into Service Mesh or Service Mesh Lite later if you want to implement that. So if you're just starting your journey, two-tier ingress is the model to start with.
Yeah, I would say that's exactly true.
Yeah. Excellent. Here's another question for you guys. Can you give us more insight into Citrix CPX?
Right. So CPX is a containerized solution from Citrix. It's an ADC in a very small form factor. It runs as a container. It has a layer 4 to layer 7 ADC functionality, like what we have in our other NetScalers and Citrix ADCs, like the external MPX, which is a hardware load balancer. What we've done is we've taken our code base that runs on the MPX, which is the hardware load balancer, and a VPX, and enable that to run as a container for ingress solutions. That's one. We've then further reduced its footprint. So we have a mode now to make CPX either a ingress controller, ingress device size, or a sidecar to run as a service mesh in a service mesh environment, and therefore run as a data plane in a service mesh environment alongside, let's say, Envoy in a Istio environment. So that's what the CPX is. It can run as a sidecar for service mesh in a low footprint size alongside Envoy. as well as it can run an ingress device in a ingress solution for Kubernetes.
And if you want to experiment with that and play around, we strongly recommend to go to github.com/Citrix. You will find Citrix CPX there. They will find configuration guides. You will find some detailed discussion about various architectures, and you can play around with the Citrix CPX and other architecture options as you learn and get more familiarity.
That's right.
Okay, here's another one. What do I gain with Citrix ADM over my other observability tools?
So let me cover that, right? So it really comes down to the type of customer. If it's a company and enterprise that's new to the Kubernetes journey, what we find typically is that they're looking for a solution from Citrix that includes the observability plane, the proxies, or they want to take their existing proxies, move them over to the Kubernetes platform. And so we built ADM for that. ADM is designed to support folks who are moving to Kubernetes or already are in the journey and have an existing ADM footprint and being able to leverage that for microservices. What they gain on top of open source tooling is, so the service graph is one. We built a service graph particularly to run for microservices. We're building the same service graph to run on 3-tiered apps and combine them together. So they gain that with us. A very rich service graph for observability allows them to troubleshoot their problems faster. And in addition, we're tying this to machine learning. The ADM running on the cloud enables you to do machine learning. And so we're only going to improve that more and more. We have some algorithms that are coming out this year, and then that'll just get better and better over the next quarters. That's ADM. However, having said that, we have customers who are already in this journey. They have their own tooling. They have Citrix ADCs. They are using open source tools for observability, such as Spinnaker, such as Zipkin tracing, such as Elasticsearch, an EFK stack. And so for them, ADM does not make sense for them. For them, they want to use the existing tooling adapted to support Citrix and use templates from us so that they can use our rich metrics and to provide them even a better solution for ingress and for service mesh so that they can troubleshoot their problems better. So that's the real reason why we support. That's really the one reason why we support both of these particular solutions. And so I think it's really more an either-or solution. So for the customers who already are deep in the journey and they have open source tooling, I think for them to continue to use open source tooling, and that's what we provide them is much richer information than they can get from other proxies.
Another benefit which you get is single pane of glass for your 3-tier web applications as well as cloud native applications. It also gives you single pane of glass for any Citrix ADC deployment in any form factor, any cloud, any deployment model. Back to you.
Excellent. Thank you. That was a wonderful answer. Here's another one about observability. If we need maximum observability, what architecture do you recommend?
So for maximum observability, you need to have touch points across all your pods. And the architecture that does that is Service Mesh. Service Mesh gives you that full access to all the pod traffic. So that gives you the maximum observability. The other one, which is simpler than the Service Mesh, is Service Mesh Lite. There, you need to design it such a way that you do send all your east-west traffic through the ingress device. In the Service Mesh Lite, all your traffic north-south and east-west goes through an ingress device. Except for cluster-specific traffic within the Kubernetes cluster, that goes through proxy. So Service Mesh Lite gives you observability, rich observability.
Just to summarize, if you're looking observability only for north-south traffic, then all 4 architectures gives you that. If you're looking best-in-class north-south as well as east-west, then service mesh or service mesh lite is your best option.
Well, thank you very much. We have some other questions online, and if we didn't get to your question, we will make sure to answer it, and we'll send out the responses in a follow-up email. That brings us to the end of our presentation. I'd like to thank Pankaj and Miko for a very informative presentation, and also thank our audience for joining us. A quick reminder, you can check out and register for other upcoming webinars and events by going to citrix.com/events. We hope you have a great day, and we look forward to speaking to you again soon.